Increasing water supply is a critical need in many parts of the world, particularly in regions facing water scarcity due to growing populations, climate change, and environmental challenges. Several methods can be employed to augment water supplies, each with its own set of benefits and considerations. Dams and reservoirs are among the most traditional and widely used methods for increasing water supply. By constructing a dam across a river, water flow can be stored in a reservoir, creating a large supply of water that can be used during dry periods or in times of high demand. Dams also help in flood control, provide recreational opportunities, and generate hydroelectric power. However, the construction of dams can have significant environmental and social impacts, such as habitat disruption, changes in river ecosystems, and displacement of local communities. The process of damming rivers and creating reservoirs also requires substantial financial investment and ongoing maintenance. Water diversion involves redirecting water from one area to another, typically using channels or pipelines. This technique can be used to transfer water from regions with abundant supply to those experiencing shortages. For example, water can be diverted from rivers or lakes to arid regions where it can be used for agriculture, industry, or urban needs. While water diversion can provide relief to water-scarce areas, it can also lead to ecological consequences, such as reduced water flow in the source area, which may impact local ecosystems and communities that depend on the original water source. Water transfer is a broader concept that includes not only the diversion of water from one region to another but also the transportation of water through infrastructure like pipelines, aqueducts, and canals. Large-scale water transfer projects can help balance water availability between regions with surplus and those with deficits. These projects can involve complex logistics and significant costs. Additionally, they may face challenges related to political, environmental, and social considerations, as the transfer of water often involves multiple stakeholders and affects various regions. Desalination is a technology used to increase water supply by removing salt and other impurities from seawater or brackish water to make it suitable for human consumption and agriculture. Desalination is particularly valuable in coastal areas with limited freshwater resources but access to seawater. There are two main methods of desalination: reverse osmosis, which uses high pressure to push water through membranes that filter out salt, and thermal distillation, which involves boiling water and then condensing the steam to remove salt. While desalination can provide a reliable source of fresh water, it is energy-intensive and can be expensive. The environmental impact of disposing of the concentrated brine left over from the desalination process is also a concern, as it can harm marine ecosystems if not managed properly. Each of these methods, dams and reservoirs, water diversion, water transfer, and desalination, offers a way to increase water supply and address water scarcity. The choice of method depends on various factors, including geographical conditions, environmental impacts, economic costs, and social considerations. Combining these approaches, along with improving water conservation practices and management strategies, can help ensure a more sustainable and reliable water supply for the future.